Hi, in today's lesson we're going to start a new theme. This is the end of the first part of the course, theme 7, I call it the geological machine. What we've now done is looked at the materials that make up the earth. We now need to move on a step. We need to start thinking about how these materials actually start to interact with each other. What are the driving forces behind the rock forming processes we've been looking at? You'll need the pink booklet. Okay, let's go. This theme then is all about plate tectonics. Plate tectonics is one of the really big ideas of geology, along with deep time, uniformitarianism, evolution and extinction. Plate tectonics is a really important aspect of understanding how our planet works. It's one of the reasons our planet is inhabitable. It helps us explain so many different geological processes, all the way from evolution through to volcanic activity, through to the formation of economically important minerals. It's almost the big unifying idea of geology. What makes it even more remarkable is that it's actually only relatively recently, I say relatively, back in the 1960s, that our understanding of plate tectonics really came into force. Before that, as we'll see, geologists didn't understand plate tectonics. We didn't know how it worked. We didn't realise the significance of it. It really was a complete revolution in our understanding of the Earth. Now, to be able to do this, there's some things we need to get started with our theme. As ever, when we start a new theme, we need to consider what's in a word. So if you turn to the inside of the back cover, you'll find there a whole series of terms, some quite big words here, that relate to plate tectonics. Can we come up with a definition for what these are? Remember, at the moment, I don't know is a perfectly acceptable answer. So have a go at that. See what you already are aware of. Okay then. The first part of today's lesson, when we start getting stuck into the data, is to look at some of the different types of crust. We have a cross section here. This is showing the top, 70, 80 kilometers of the Earth as we draw a line that cuts right through South America. So on the left-hand side, we have the Pacific Ocean in the west. In the middle there, we have the continent of South America. And on the right there, we have the Atlantic Ocean. If you want to find an atlas, this cross-section is actually drawn along the Tropic of Capricorn, 23.5 degrees south. Okay. What I would like you to do is I want you to plot the bottom of the crust across this diagram. You've got a table with the thickness of the crust at each of the places that's actually marked. The thing you need to bear in mind is that the data you've given is the thickness of the crust, not its depth below sea level, its thickness. So if there's any height above sea level, you need to take that away from the thickness to be able to plot its depth below sea level. You should then have a whole series of dots that go across the across that page, I'd then like to join those together to show the shape of the crust. And then can we annotate that to show some of the differences between the different types of crust? We have oceanic crust and we have continental crust. What can you see as the difference? So, press pause now and have a go at that. See what you can come up with. Okay then, let's see what you've been able to plot. So we're looking to plot the base of the crust on this cross section through South America. If we plot the thickness of the crust at each of these places and then join them up, what we should see is a line that looks a little bit like this. You can see that the thickness of the crust varies tremendously. Let's add a few more labels to this diagram. So, this thicker part of the crust is the continental crust. The thinner parts are the oceanic crust. We then have beneath that the mantle, and the line you've plotted is actually the MOHO, the Mohorovicic discontinuity that we talked about way back in theme 2. Let's look at each of these in turn. So the continental crust is the thickest part of the crust. Notice that where we have the thickest part of continental crust, that's also the bit that's highest. So underneath the Andes Mountains there, that are about 5 kilometers high, we've got about 75 kilometers, or 70 kilometers or so, of continental crust. That provides the buoyancy to keep those mountains higher above sea level. So the continents are the bits above sea level because we've got this very thick section of crust that's actually relatively low density. So if you like, it floats, in inverted commas, higher in the mantle. The oceanic crust is thinner. It's also far more uniform in thickness. 5, maybe 10 kilometers thick at most. The oceanic crust is, as well as being thinner than the continental crust, is also denser. That's why it sits lower down on the Earth's surface, which is why it's covered with the oceans. The mantle then is this layer of the Earth, this very thick layer of the Earth beneath the crust. That's denser than both the oceanic crust and the continental crust. That's why those two types of crust sit higher up on the Earth. The boundary between the two is called the MOHO, named after the guy who discovered it. So, these different thicknesses of crust are actually really important because when we start looking at how the different plates actually interact with each other, these differences in thickness and density actually help to explain a lot of what's going on. But we'll get to that in a future lesson. What I'd like to do now, though, is think about what you already know. This is a plate tectonic map showing us the main plates. It misses some of the smaller ones, but it shows us the main plates. and some of the events that can occur. What I'd like you to do is I'd like to annotate this, this map as a digging deeper activity. What do we already know about plate tectonics? What have we learnt already? What are you aware of? What type of things do you think we can be discussing in more detail as we make our way through this theme? Okay, as we watch the sunset on Mayon volcano in the Andes, we have seen now that the crust varies. There are two main types of crust, the continents and the oceans. Their thickness and density determine the shape of our Earth's surface. But it goes beyond that and will start to determine how these plates, or how these types of crust, should I say, will behave when we get into a plate tectonic situation where we have, particularly around the edges of plates. But that's for another lesson. I'll see you then.